Let's start our session. Welcome that you find your way here. After lunch, it's always a difficult spot. People are either eating or half asleep. So I do my best to keep you awake. Topic. I called it very clickbaity, how to Skynet your Kubernetes clusters with LocalAI. We're not going to make any Skynet world domination stuff, but the LocalAI part is true, so that will be very interesting. Quickly to my person. My name is Engin Diri. I'm working at Pulumi as a customer success or customer experience architect. Cloud transformation and enablement is all what I'm doing. And you will see at the bottom some of my socials. Feel free to follow me, drop me a like, as you wish. And if I'm not doing stuff around cloud native, I'm of course thinking about the Roman Empire, because accordingly that's what mans are doing when the whole day, and I'm no exception on this. So Roman Empire for me. I should think about Texas more, maybe that's to change this, because I'm quite impressed. The stadium looks also like the amphitheater of Rome, so that's cool. Okay, let's go for the question. So I have to say something to put you in context. This area is so quickly evolving. What I put up here on the slides could be already old news, because every day there's something new coming. Please bear this in mind when you see the context that things are so quickly evolving in the AI space that it's breathtaking. So when we thought about AI, and say when I go to my parents or talk with my colleagues and we think about what is AI, we have, of course, first always this kind of impression in our mind to say, oh yeah, there will be something. And now we come back to my title, Skynet Terminator. One day the machines will take over and we are doomed. That's literally. So there was at the beginning of ChatGPT, people really gave the advice to say, hey, be nice to the AI. You never know. When they gain conscious, then maybe they take revenge on you because you did not treat them very well. So always say thanks and bye. And there was a talk of Scott Hanselman during the last GitHub conference where he really could show you that when you really use thanks and please, you get better result out of the model. So that was also something I did not know. So I always thought that's funny because people are making joke about the machines, but actually the way the models are trained, they really react and give you better output when you say please. So interesting. Okay, but of course not. We now know, after probably more than 1 year of into the hype and really seeing usable results, it's not about a Skynet or machines going to destroy us for now. So this is more what we think about when we talk about AI, to say, okay, this could be a future where we get much of the toil and much of the chore automated from large language models who take care of taking out of the boring parts, for example, or you can ask the question. I mean, I have to be honest, sometimes when I send a mail out for people with an English background, I let ChatGPT correct the stuff. So I always paste in and said, can you make please a mail what Americans would also like to read? And he completely gives me something nice, because you may notice I'm from Germany, so English is not my first language. Okay, the future. And of course, we saw now with the recent release, it maybe not looks obvious. This is OpenAI, Sam Altman. And we saw recently the release of Sora. So we reached a level where we can create by text also videos. They're looking really breathtaking. It's amazing. If you ever worked with DALL-E 2, for example, and compare it with DALL-E 3, it's worlds between. So we see OpenAI, highly valued company, but also other players highly started to jump on this. We see Google announced Gemini, or released Gemini. We have Amazon working on different foundation models. We have Meta with Llama. So we see larger companies, or the big tech companies, bring out their foundation model and embedded it into their business model. So AI and having access to AI is a business model. And then we have also here, let me play this, the differences between 1 year ago, the famous Will Smith eating spaghetti, and now how it looks like now. But can I play this again? Of course, this is a fake. Will Smith released this on Instagram 2 days ago, and he just recreated it. So the bottom thing is literally really Will Smith, but he joked around the AI thing. Okay, so a hot topic, of course. So should we all now swim in money? If we as developer, as company, and we see plenty of companies jumping on this, is this something which will make us rich? Switching to AI, trying to embed AI into our applications, whatever use cases we have. And me at Pulumi, of course, we have our customers who started also to think about this. So we were invited to meetings where customers said, I need AI. And of course, so wait, that's me now. So that's me as Pulumi. They asked how we can also benefit from this. And we now have to divide between two types of customers. We have our startup, our born in the cloud customers, as we call them. They are, of course, cutting edge and so on. But then we have also our enterprise customers. And they have now the challenge to say, I want to use AI, but now comes the big but question. And I would like, even if it's difficult here, to pass the question, what could be some of the questions our customers asked us? What do you think? What are the reasons for large enterprises to think about if, and now I don't want to spoil the answer, to say, okay, if there is another way to use AI without going to one of the big providers, let me say like this. So feel free to give me any ideas. I have some, and I will compare them what you come up with. So why should enterprises have concerns or hesitate to use one of the publicly or to the one models we all know, like ChatGPT or GPT? Huh? Yeah. Let something for the others. But all right, they're all good. Yeah. Protecting secrets, absolutely. So just to re-say, so for the recording, we got costs, we got transparency, we got security, and what was yours? Yeah, secret. Okay, so I put some of my stuff, and this is again highly opinionated, and as we saw, there are many, many more other reasons. So first of all, costs. Yes. It can become quite expensive. So it's always like a drug dealer. You get the entrance very easy and so on. But then things, as soon as somebody said vendor login, as soon you're in, it become very pricey. And depending on what are you doing, it can be really, really pricey. Playing around as a developer, I knew this from my former place also. When we had developer access to the cloud, we really burned everything. There was no cloud compliance at that time, so you could really provision everything. Privacy, somebody mentioned. So starting to send stuff to an AI, a closed AI from somebody else, you don't know what they're doing. So if you start to send some of your business informations and so on to these providers, what they're going to do? Will they be used to train? There was some incident that people could ask, I think ChatGPT or something, and they get results from a model trained from, was it Cisco or something like this? So there were some informations started to pop up in some of the answers. That can be an issue, especially for a company. The next point, transparency. We don't know how this model is trained. We have no idea about this. We just consume it, but have no idea how the foundation was set up. That can also be an issue for companies to say, okay, that's not how we would like to do. And last point, another point is vendor login. We had it, yes, of course. It's like everything. The aim of every company, and yes, I'm working also for a company, is we need to get the people in. But sometimes the question is, do you want this, and do I want to evaluate the options around this? Because maybe I have to switch. Maybe there's an issue with this, and I need to move somewhere else. Last point, maybe not that big, depending on the state you are, is of course you want to run experiments. you want to check benchmarks. So there are huge tables out there where you can compare different foundation models and say, okay, how do they perform? So, okay, great. All understand. That's really cool. So let's see how we can continue. Now comes the next point. I said now relatively positive stuff, but we know there is no light without darkness. So there's also challenges around using an open source large language model. So let me put also some of the challenges. I hope we can see this well. One, of course, is again cost. So this is a little bit strange. We have cost on one side. We have cost here also on the open source one. Yes, we need to implement the open source model and we still need to invest a little bit time into it. So we have here a cost burden. Latency, you will see when I prepared the demonstration, latency is really a problem. So you should have some hardware and some connectivity that you get the best output out. So I run it, for example, on an EKS cluster without a GPU support, and you can really see it takes the time to give you an answer. So you have to really be careful how you perform when you're using an open source. Operation, of course, now you have to take care about this. We have operational burden, and as you may notice when you're a little bit more in this space, it's still not that simple. So you still need a little bit expertise, knowledge around this, so it's not that easy. But again, the options getting better and better. When I started this talk and prepared the talk, Ollama 2 was not available, for example. And now I have Ollama 2. I can create a Ollama file where I can really customize my model. That was not available at this time, so things getting easier. Yeah, coming to the choices to say, what choices do we have currently? And I'm sure you may know additional models, systems to run locally. I opted now here for this solution. So we have a LocalAI. That's the one on this side. On the right side, we have Ollama. And we have this VLLM. I didn't try VLLM, so I don't know how good it is. I'm not that... that was, I think, in Python, so I was not that firm here in this case. But doesn't matter, I concentrate on LocalAI. So that's the thing I want to show you. So, LocalAI, I put a little bit here the architectural diagram of LocalAI. The core of LocalAI, again, it's an open source project, just to emphasize this again. It's written in Go. On front of the LocalAI Go engine, we have an API. And here comes one of the clues. It's OpenAI compatible. So you can easily drop, if your application in prod, for example, still goes for the OpenAI API, you do something in LangChain, and and you don't want to use this, for example, in your dev environment or in your pre-prod environments, you can just change the model and say, okay, now go to this server, it's compatible, and you will not see any differences from the implementation perspective. So that's really, really cool. And of course, one advantage of LocalAI is also you can, it's communicating via gRPC to your actual models, and you can implement a whole lot of models. So for example, in my demo example, I use GPT-4All. That's an open source project where everything is visible, how they trained the model, and the idea of GPT-4All is also to democratize the large language models and give people the more insight. But you could change to any other one. So as long as you have access to it, you can use it. It uses, as I said, gRPC to communicate, and it doesn't matter how it's implemented. So we have also Rust. So that's a really cool approach. The last point of LocalAI, what makes it also really cool is you can deploy it on a variety of deployment targets. So we have, for example, on Helm charts, we can deploy this on a Kubernetes cluster, for example, be it on-site in your edge locations, for example, be it on a cloud environment, it doesn't matter. You can run it on Docker. I hope this is a little bit visible, so you can run it on a normal Docker engine. You can run it in Fargate if you want, for example. And of course, you have the local CLI. So you just can run a LocalAI, point to the folder of your model, and there you go. It's the whole story starts. And then, yeah, as I said, on the consuming side, we have done our AI-powered applications. They can be accessed from your customers, no problem on this. You can create a web, you can create a mobile application, depending on the libraries you're using. And on the top, you see the developer. He can also directly communicate maybe to the API without any between implementation because he wants to test something. Okay, so far to the explanation. So it's not rocket science, the system. LocalAI is really easy to start play with, so you can just clone it. There are plenty of examples, and you can just, during startup, you can say, okay, I want to use this model. LocalAI provides a model gallery. You will see this. I show this in the demonstration. Just choose which one it should be installed, and you're good to go. Okay, here the QR code for the demo code if you want to follow along. And let me open this. The demo architecture, just to give you an idea. So I provisioned an EKS cluster. I use Pulumi with TypeScript to define my deployment. And then I install 2 applications on top of it. That's LocalAI. And of course, I use Flowise. Flowise is a no-code, low-code AI application builder. You will see this also. That's not part of the talk, but it makes very easy to connect your local AI with, for example, embeddings and with vector stores and so on. So the second demo will be a little bit more sophisticated because we will solve again a challenge you will quickly see. Okay, let me just change. And it's really difficult when you don't see the screen to correctly show everything. Yeah, that's absolutely rubbish. Where are you? Where is my mouse cursor? Ah! Here. Here is it. Okay, so. Okay, there it goes. Okay. Everything starts here with the deployment code. Where is it? Here. Let me make it bigger. So the first part is the Pulumi code, just defining an Kubernetes cluster, an EKS cluster, defining the VPC. So this is all related to the cloud. If you're using AWS, you may already understand, oh yeah, okay, that's this very tricky. We have here our cluster definition. And as you cannot see this, the node type, I choose a very large one, so I think it's 16 CPUs and 32 gigabyte of RAM, so I really put much power onto it to give you a little bit more snappier experience. If you would run this maybe in your productive environment, you would choose a node working group dedicated for this deployment of the AI, tainted that you not accidentally deploy any other application on it, and mark your deployment in Kubernetes to say, please deploy this pod only on the worker node with this GPU support. So that's one thing. And now we come to the next part. I defined also an EBS driver because I want to store the model on a storage device. And last but not least, the mouse. Where is the stupid mouse? Okay. And then, of course, we have here the deployment of our local AI Helm chart. And this next part, I swear that's... I can't see my mouse cursor. This is annoying. Okay, just a second. Let me mirror my main screen, then it's a little bit better. So where is my mouse cursor? Okay, so let me close this one here. So as I said, defining here the deployment, you could use also Argo CD or Flux, depends on how you're going to deploy. But as I said, that's not the idea of the talk. But here we can see now I define some properties of my LocalAI model. I define the galleries where he has access. LocalAI has sogar access to Hugging Face, so you can download models from Hugging Face when you say, hey, I want to use this model, because there's also plenty of open source models available. In my case, as you can see, I also request here 8 CPUs and 32 gig. Man, this is so I'm sorry, that's not the best interactive setup. The thing is, I don't see my mouse cursor neither on this stupid screen. So, come on. Where is it now? Finally, where is the mouse cursor? Here you are. So, now he shows the main display. Okay, hope this is better. So, setting the request for the pod, of course, that's not something unfamiliar. And here we see the model I want to download here, for example, as I said, the GPT-4All model, and then setting some persistence. So that's the one part. I then can use Pulumi app to deploy the application. I did this already. So let me show how it looks like when it's already deployed. So let's open K9S. And we can see here now, hopefully, that's a little bit small. All the deployed, that's the services. And we can see here all the deployed pods. So we have FlowEyes and we have LocalAI is deployed. That's very interesting. The rest is not from concern. So now let's exit FlowEyes. I just make a port forwarding. I did not create now some kind of ingress. And now we can go, this is now the UI. I can now here go for creating a new workflow. And as I told you, you just click and drop the stuff. So that's very, very good to create from different sources. You can create an accumulation. So it's a very cool tool, which not require you that you program. I created now 2 flows. One I called simple, because the other one is a little bit more interesting, and we will see also the second part and the problem we have. So now here, simple chain. As you can see, I connect to my LocalAI. I use the service of Kubernetes. I say which model, yes, because I could have several models running in LocalAI. I select the GPT-4. I set the temperature to 0 to reduce any made up stuff, to keep stuff very on point. I don't created any additional templates, so I'm not putting some prompt engineering into it to try to get the best out of it. Here we really go straight. What I enter here on the right side will be sent to the language model, and here we can connect and say, okay, please take the language model, take the prompt, and then use this. So in my case, let me ask a question. It takes a little bit of time, so I prepared everything. So I used a question because I want to show you a specific problem here, but this is the idea we will solve later. So I asked now a question, how are you? Everything works fine. We all know this behaves similar to ChatGPT, we all know. So what I'm trying to do now is I ask a question which is relevantly new. So I know that the model is trained with, has a cutoff date. So I'm not expecting that it will come an answer which is true. And the downside of this kind of questions with a large language model is I could say to him, if you don't know it, then don't answer it. Here in this case, as I said, I don't put any energy into the prompt template to give him specific instructions. You will see he's like my buddy from school. He doesn't know it, but he still comes up with something, you know, some bullshits, and then you believe it. So that's the thing. And here we can see, takes some couple of minutes, but the question I made before as a backup is, he says the iPhone 15 has, the Pro has a 12 MB rear camera, and so this is completely shit. That's not true. That's not the specification of the iPhone 15 Pro. So that's the thing. I let it run. As you can see, it takes a couple of minutes. Again, you can tweak this to give better answers using a GPU. Or you run it locally on your machine with NVIDIA chipset and so on. So from the power, you can do everything. And local language models really benefit from having a powerful hardware underneath. I think there are even discussions to create dedicated AI chips who really are meant for this use case. Okay, so let's continue. Play from current slides. So we see this demonstration. I will go back when we finish this part and show the result of this one. Do we see? Yeah. Okay, so now is the question when we look a little bit around and see, okay, I made now the example with the iPhone 15 Pro. So we see that LLMs suffer from several drawbacks. And this is not bound now to local AI or the system underneath this, but this is a generic thing. So we can say one of the drawbacks of using an LLM is that the knowledge is static. They call it frozen in time for the moment it was trained. So when the cutoff date was in September, whatever, or last year, everything after this is not considered. So as you can see, he come up with things this is completely made up. What we also see, and now we come back to our customer, there is no domain-specific knowledge. So when a company wants to use AI for their internal documentations or to make life easier for internal folks to ask specific questions to get output, any large language model you get will not have this easily. We will see. And if we want to get this domain-specific knowledge on a classical way in, it's very costly and inefficient to produce because there's a system called embeddings. And you cannot take everything and embed in your large language model without, I don't want to spoil again, without the usage of vector stores, for example. It makes your overall performance of your large language model very bad. So, and if you don't want to use this inefficient way to embed your knowledge in, you're not going to train a foundation model on your own because we come now back to everything else. You need special persons, you need special knowledge. So it's also very costly to produce this. So as we can see here now, the question is the same I did before. We have our search, our generative AI search. We ask a question without any context here. In this case, how many megapixels has the camera of the iPhone 15 Pro? And then we come up with some stupid stuff. So when I run this before, he just told me the iPhone 15 Pro has a maximum resolution of 108 megapixel. Bro, that's not a bad camera. Okay, so a completely hallucinated answer, that's not something what we want. So here's another thing which comes to our rescue. It's called Retrieval Augmented Generation, RAG. And what RAG is helping us, we avoid training our own foundation model. We are not Sam Altman and burn here $100 million to train our foundational models. We're not having the time for fine-tuning, adapting the foundation model. We talked about this. And we know, as you can see, prompt engineering using a prompt template brings you also on only a specific point. You can whatever say, hey, imagine you are the seller of a Apple store, you know everything about this, will still not help you. So RAG is here the cost-efficient answer to, and now we come to the point, to embed in your existing model actual data, so external data, in a kind of vector database. There are also different providers of vector databases. I made the example here now with Pinecone, which offers the service. And what you can do now is during you can ingest now the data. You can say, I have a Confluence, I have CVS, I have JSON file. You have even the option to use APIs. So get the information out and then create the vector store embedding in your language model and store the data itself in the vector database. I will show this how it looks like in Pinecone and how I did this. And now, what you have now is you can now ask a question with context. And if we ask again for the question and say, hey, how many megapixels does an iPhone 15 have? We will see now a different result. So let me switch to this demo. Okay, that was the example. He's still calculating, probably the latency here. Okay, now we go back and we say we want the iPhone with vector store. So let's look how Pinecone looks like when we go into the Pinecone application. So I created here the iPhone index. Pinecone has two different ways of indexing. They have a serverless approach where you don't need to think about the underlying infrastructure, or they have an approach where you can define the pod and say, I want a specific size. I opted here for the pod approach, and as you can see now, all the informations are in. So he started really to extract the site and build, depending on the chunk size I set and the overlap, he started to create the entries and give them different scores, because we know our vector database is depending on the distance of your question. You have this X, Y, Z coordinates and then going through and so on to get all the information. Okay, so let's have a look how it looks like. So here, I said to him, go to the page Mac Rumors. So I went to the page. I can show you the page. I hope. So there's all the informations about the iPhone 15. And somewhere underneath, you will see the camera display. So here, somewhere. Display, dynamic eye, always on. Yeah, somewhere here you will see, here, there is it, some megapixel descriptions. So actually the iPhone has a 48 megapixel camera. So I told him, please use this website to get your additional informations. If we can go here into the documents loader, as you can see, you can create different one. Everything can be codified if you use LangChain. You don't need to use here Flowwise with a low-code approach. But as you can see, I can now say use different sources. There are plenty of more. You can even create your own document loader. And what I then said, okay, now we use also the embedding here. So I created, in LocalAI, I created an embedding model, BERT. and it takes care that you can embed the informations in. And now I have here this how do you call this? This element where I can say now, okay, now make the upsert of the document. I give the Pinecone index, the credentials. I connect it with the documents. I have here a markdown text splitter to keep things smaller, because sometimes it's needed that you cut the source into pieces. Here in this case, I said, okay, please make translate it, create a markdown, and the size is 400. And here at the end, I create my retrieval QR chain. So now there's a different underlying chain I have to use, and I can point now to my vector store and to my language model. And if we ask again the question, how many megapixels has the camera of the iPhone 15? You will get now the iPhone 15 uses the same 48 megapixel. Okay, so as you can see, the answer is now much, much more qualified, and this is really a quick implementation. So you can guess if you look the informations you're feeding the system, you get much better stuff out of it. Okay, let's see if the go out here. No, this one is not coming back. Okay, so that was the second demo. Here the graphic I create. So we have now an additional Pinecone index, nothing else here. So as we run out of time, some of my key takeaways, very bold statements. Of course, bold is very good. So open source LLMs are hot. This is really something we will see people in the community ask around this and say, yes, I would like to have an open source LLM. I maybe not want to go to one of the bigger ones, so check this out, check the list and see if some of the models are suiting your use case. Running LLMs locally is completely legit, and it makes sense, as you can see even with this little example, it makes completely sense. And using RAG makes LLMs smart, I would say, so you can embed cheaply and easily additional informations which are not available during the training time. And yeah, that's it. So I would say, as a to-do list for you folks, because it's quite loud here and so on, so go try LocalAI at home, play a little bit on your local machine, see what happens. And if you find it still interesting and you want to learn a little bit more about, for example, Pulumi, we have a Pulumi Austin PUC this week on the 22. And you can meet with people here in the local community about infrastructure as code. Because I'm here from Germany, they invited me also for a talk, so I will talk about self-service infrastructure. And that's it. And I think we have no time for questions. This one? Yeah. But you just left. But look, I run away. Okay. No, feel. We can talk later then.